I want to welcome everyone to this webinar and let you know that my name is Hannah Sheridan. I'm an engagement and operations coordinator with Seneca Solar, and I also want to tell everyone Nyaweskino. That means I'm thankful you are all well in Seneca. So we are very excited to host this webinar today on groundbreaking business model innovation that builds a more efficient, durable, and recyclable smart solar panels domestically, uplifting communities with high quality jobs. So let's get right into it. I'm going to go over a few housekeeping items. And while I do that, I would love to ask everyone if they could, and it seems like people have started, drop your name, your company, and where you are calling in from. We love to see how far away people are calling in, so that would be great. Now into some housekeeping. So this is being recorded and we are going to send out this recording to everyone that has registered within the next couple of business days. So be on the lookout for that. And we have a chat function, which everyone is using right now, and a Q&A function. So if you have any questions, please use the Q&A to filter all those questions in there, and we will have time after the presentations to go through those questions. And I want to let everyone know that if you do want to be able to speak to our presenters, you'll be able to, at the end of our presentations, raise your hand and we will take you off mute and you can talk to us. Just another note that if you have any questions about Seneca Solar, you can email us at info@senecasolar.com. Alrighty, let's get into our presenters. Let me pull up this bio. All right. Devin Hartman is the executive director of CHERP, Community Home Energy Revolution Project, which he founded after retiring from his decades-long role as co-founder and president of Hartman Baldwin Design/Build. CHERP began with the goal to form collaborative partnerships with cities, counties, community organizations, and contractors to promote sustainable building practices and the reduction of fossil fuel use in buildings throughout California and beyond. Now, CHERP Solar Works is building solar panel factories around the US, which we'll hear about today. Devin has won numerous awards and his work has been featured in many publications. So thank you, Devin, for joining us today, and we'll hand it over to you in a little bit. Next is Matt Renner. He is vice president of Seneca Solar, a tribally owned and controlled earth healing solutions company. Seneca Solar is focused on helping commercial customers achieve ambitious climate goals while supporting the long-term well-being of the Seneca Nation and other indigenous people. Matt has worked as a nonprofit executive in clean energy, climate policy, and journalism for over a decade, focusing on the near-term social and economic impacts of climate change. Thanks for being here, Matt. And finally, as I mentioned earlier, my name is Hannah Sheridan. I am an enrolled member of the Seneca Nation. I'm Bear Clan, and I'm the engagement and operations coordinator here at Seneca Solar. I attended Yale University and was a history major with a focus in environmental and native studies. And so that kind of grounded me in knowing that I wanted to come back and work for my tribe and be in this space. And I'm very happy to be here today. So I will give a little context of the Seneca Nation so everyone is aware, and then I will hand it over to Matt to talk about Seneca Solar. But the Seneca Nation, we have a bit over 8,000 enrolled members. We are traditional homelands, and where most of us are located today is in Western New York. We have two main territories, the Allegheny Territory, which I am calling from today, and the Cattaraugus Territory. So we take pride in our land, and Native people and Indigenous people have always been great stewards to the land, and so that's something so special about talking about this webinar and calling in from the Seneca Nation. And I'm really excited to be here today, so thank you. And I'll give you a little bit more background on the nation on the next slide. So we have several lines of businesses. Here's an example on the side of a few. We have the Seneca Gaming Corporation, which is our economic engine of the nation, right? So excuse me, that helps bring income directly back to the nation, right? To support our cultural endeavors, our health endeavors, any of the infrastructure. And so that's been a really great support to help build the nation up, and again, to help sustain our culture and pass it on to future generations. And with the gaming corporation, we have Seneca Holdings. And so Seneca Holdings came about to diversify the revenue coming back to the nation away from gaming. And so with Seneca Holdings, we have gotten into some federal business, some healthcare business, and finally the Earth Healing Solutions business, which is something that aligns so well with the culture of the nation. And that's all Seneca Solar. So I will hand it over to you, Matt.
Thank you so much, Hannah. I really appreciate the intro and the background on the Seneca Nation. I think that the key to understanding what Seneca Solar is all about is really grounded in the role of the nation and the intention of the nation to do business that really aligns with the future and where we need to be headed as a society and as a civilization. So Seneca Solar is a relatively new company. Our founding mission is to profitably and equitably deliver innovative renewable energy solutions that heal the earth. And we strive to do the most good for current and future generations. This is key because we all know that the renewable energy revolution is underway, and we need to really focus on how to execute it and build it equitably and not recreate the same systems that have led us to the brink of destruction as the ones that are currently in place have. So as a tribally owned company, all of the profits from our work as a solar developer go back to the Seneca Nation to support reinvestment in their economic activities and to support the people and the health services and the on-territory work that's going on. It's really important to understand too that the Seneca Nation doesn't collect taxes. This is their economic engine, is their business enterprises. So this work directly benefits a community that's been historically underinvested and left behind by the mainstream economy. Our values and our legacy are focusing on healing the earth with urgency, delivering exceptional solutions for our clients, to train and employ Native people and underserved communities, and to advocate for future generations. All this is done through the lens of thoughtful and collaboration and solidarity. The services that we provide with those values in mind are strategic advisory services, consulting and project management. We can actually do solution development and delivery for full projects, renewable energies and other earth healing solutions, and tribal engagement. One of our main goals here is to work with other Native American tribes and other indigenous groups around the world. And we have some interesting projects on that front that I'll touch on. I also want to let everyone know that these slides will be available. If you're interested, just let me know and we'll send them out to you so you can do a deep dive. Also want to highlight our partners. Seneca Energy is actually established as the on-territory utility company for the Seneca Nation. So they do the work on the Seneca lands, and they're one of the most innovative on-territory renewable energy and utility companies in the country. They've done amazing work under the guidance of Anthony Giacobbe, and their work to actually build solar projects and a wind turbine that serve the community are exemplary and talked about a lot by the Department of Energy. They've also managed natural gas and broadband services for the residents, and are just finishing connecting folks to those broadband wires that they laid. They have a whole portfolio of projects that I'm not going to go too deeply into, but definitely check this out when you review the slides. And potentially the most transformational piece of our work that we'd like to see really grow with our project is workforce development, to actually train the workforce of the future. When we work on tribal lands and off, we'd love to have as many people from those communities actually participating and learning along with our development teams. Lastly, I want to focus on why we are hosting this webinar, which is that we really feel a kindred spirit and alignment with the folks from CHERP. We see tribally owned renewable energy as a key to the future of an equitable renewable energy economy. It brings together many of the key components of the future economy that we need to develop in terms of equity, not just fairness, but actually ownership of assets, right? The business definition of equity. And we see the folks from CHERP focusing on a business model innovation similar to this one that really locks the benefits of this renewable energy transition into communities who are on the front lines and who have been most impacted by the fossil fuel economy. So it's a pleasure and an honor to introduce Devin and the team from CHERP, and I'm really looking forward to seeing what you got for us, Devin. And here's my contact info. So feel free to grab this, and then you can take it away, Devin.
Thank you, Hannah. Thank you, Matt. Really appreciate the opportunity to be here with all of you. We find ourselves today, August 11, 2022, at a particularly serendipitous moment as the federal government moves toward enacting some very powerful legislation right at the time where we understand that our social and environmental crises are growing day to day. So we find ourselves really at right in the middle of a tectonic shift. We see wealth continuing to be extracted from our lowest household income families to the top 1%. We see our environment continuing to degrade at unprecedented rates. And we could be, and I think all of us probably on this call wake up struggling to find where the point of hope lies. And I think that right now, all of us at CHERP every morning take courage in the fact that we now know that there are millions and millions of people around the world who are focused on these issues, along with all of us. And now the other plate that is moving at the federal level is going to be shifting some resources in our direction. So we have a moment here to make a difference. And I would just like to say that whatever we have accomplished at CHERP and also at idealPV, the technical side of this endeavor with Kent Kernahan, the inventor here, we now know that we would not be here without the support of hundreds of people from around the country, as well as the support from the state of California to launch this first prototype project. And so we take very seriously these kinds of opportunities to make new friends. We welcome all of you. I see in the participant role dozens of people that we have known from the beginning who've been in support of what we've been doing for the last 10 years. And lots of new people that we all welcome, because we all need each other at this point. This is a community collaborative effort, and we're grateful to be a part of this right now. So I'm going to share my screen. My goal this morning is to maybe feed you with a fire hose a bit. We want to give you the entire overview of our strategic rollout plan, combining some cutting edge technology with a novel deployment methodology. But first of all, let me just start by telling you who we are at CHERP Solar Works. A definition is critical for your understanding. What we do is we build micro solar factories for nonprofit organizations in underserved communities across the country. So I'd like you to understand right up front what we're doing. CHERP's goal is not to own 1,000 factories across the country. CHERP's goal is to inspire local 501c3 ownership of production capability and to be able to create inside the local economy a solar module assembly factory so that we can start the addition of a value chain to be able to create and deploy energy inside local communities so that we start creating and keep the entire value chain inside the local community so that profits can be recirculated as many times as possible inside the local economic unit. To that end, we have actually now created, after 7.5 years, the first nonprofit solar module assembly factory in the world in Pomona, California. As you can see here, this is a world-class solar manufacturing technology factory. We're combining that with some new technology that will give us a competitive advantage on the world stage. So this is our factory in Pomona. We are not only a solar module assembly factory, but we are also a workforce development factory and also an economic generation engine inside a local community. And we intend to contribute to the American solar manufacturing renaissance that is being underscored and supported by the federal government at this point. So we have a fourfold mission that works synergistically with each other to create a very powerful and scalable effort. First, of course, we are focused primarily on stopping global warming. Second, we want to bring back middle-class manufacturing jobs. Third, we want to stimulate local economies. So it's not enough just to create a job, because we know that Starbucks can create a job in our community. What we want to do is locate ownership inside the local community so that profits are not extracted, but recirculated. And finally, of course, the entire effort is going to be focused on the equity and justice gap that's widening in this country. So we have the opportunity now to create renewable energy and sustainable economics at the same time. So how are we going to do this? This is the major question that we've gotten over the last 7.5 years. How do we essentially compete with China with solar panels? You won't believe the number of people that have suggested to us that the United States can no longer make a solar panel. And we also understood during the beginning of the pandemic that we also could not make paper masks anymore. And so we've decided that, yes, why not? Why shouldn't the United States make solar panels again? We used to. In fact, the technology came out of Bell Labs. We used to make the solar cells and the panels. And yet now 94% of all solar panels distributed in this country right now come from overseas. So we have a 2-point strategic advantage in the world marketplace. Number one, we are going to distribute the most advanced solar technology in the world. Already has 2 patents issued on that and 6 more patents pending, with more in the works. And number two, we're going to deploy this technology in a blended, nonprofit, for-profit business model. These 2 things combined give us a tremendous competitive advantage over our top global competitors. And so what I'd like to do right now is give you a very quick overview of the technology and our business model, because it's the combination of those 2 things that are actually the biggest invention that we're going to deploy and how we're going to create tremendous leverage right here in the United States. So number one, let's talk about the most advanced solar technology in the world. We partnered with Harvey Mudd College 40 years ago, and on this call we have Professor Dick Haskell, emeritus physicist at Harvey Mudd College, who has been doing experiments on our technology and validating the patents and the proof upon which the technology is based, has just written a paper that was published just this last month in the IEEE Journal of Photovoltaics. This has proven in a head-to-head field trial against legacy solar panels that we actually have eliminated something called reverse bias, causing hotspots in solar panels. So just a quick overview. Our technology, of course, will be made in America in the heart of our most disadvantaged communities. We have radically simplified the manufacturing process, not complicated it. We have used industry standard tooling and processes and materials. We have fewer, less expensive materials and parts in our solar panels because the architecture has been simplified. For example, we have no multiple circuits and zero bypass diodes in our solar panels because they're not needed. We have more powerful and longer life in our modules, and so our overall levelized cost of energy is competitive with anything in the world market. So the technology has been validated and field tested at Harvey Mudd College. We also now have a technical board of advisors, including physicists from Harvey Mudd College, New Jersey Institute of Technology, and now more recently from Texas A&M in San Antonio, that wants to partner with us in bringing a factory to San Antonio. Very quickly, for those of you that are not aware, the problem of hotspots caused by a phenomenon called reverse bias in a solar panel has plagued the solar industry since the invention of silicon solar in 1941. As you can see here on the left, during our field trials, a conventional or legacy solar panel on the same day and the same moment as our panel on the right is creating a number of reverse bias situations and causing hotspots. This particular hotspot on the left is causing a solar cell to rise in temperature from about 120 degrees Fahrenheit up to, at this point, over 240 degrees Fahrenheit. You all know that temperature of boiling water is 212 degrees Fahrenheit, whereas in our solar panel on the right, the highest temperature is 144 degrees with zero hotspots. This is another study, a classic study in the industry, looking at the deleterious effects of various hotspots. This particular hotspot has achieved a temperature of about 300 degrees centigrade. That equates to about 500 degrees Fahrenheit. These kinds of hotspot conditions are very dangerous, and they are ubiquitous in all solar panels on the planet, except for ours. As some of you may know, Walmart entered into a lawsuit against Tesla a year and a half ago. This is a photograph from one of the 7 stores, Walmart stores, that caught on fire due to hotspots a year and a half ago. Hotspots can not only get hot, but they can create plasma arcs that will melt through any material on Earth and can actually burn buildings to the ground. Hotspots also are blistering backsheets now, and as you can see in the lower left-hand corner, hotspots are the cause of the discoloration of the laminates and the EVA inside a solar panel, causing yellowing, which is the primary cause of degradation in energy output and function of solar panels over time. The latest report out of NREL suggests that in the industry today, degradation in solar panels is twice what the industry is claiming. The problem with degradation is that as our solar cells become more efficient, the problem of hotspots becomes greater because there's more energy being forced through these conditions that create heat, and so the heat is more intense. So without going into it too much more deeply, our panels will not only never create a reverse bias or hotspot condition, but also they will be the safest panels on the market. They will automatically shut down in a millisecond if they do not sense an inverter. So they will not create energy. So they will not kill firefighters who have to go on a building. They will never create a plasma arc. There is no zero single point to catastrophic failure. We have massive redundant interconnects and repairable solar cells in our panels. So we can go into a lot of these details later. The physicist on the call, Professor Dick Haskell, is the author of this journal article that has been peer-reviewed 3 different times by IEEE Journal at Photovoltaics. And we can discuss this offline later with any of you who are interested in digging deeper into the details of the physics and the electronics of the solar panel. The second advantage that we have is to deploy this technology inside what we call the blended nonprofit for-profit business model. Each independently owned factory by a 501c3 inside a local disadvantaged community or underserved community across the country will be a nonprofit factory. We're calling those factories locally grown power. That will be the network, the nonprofit network in which all of these factories will operate. So each locally grown power factory will be nonprofit so that that factory can take advantage of all of the suite of opportunities granted to a 501c3 public charity in this country to be able to help us reduce costs. So for example, the first prototype factory was primarily stood up by a grant from California in the 2019 budget disbursement of $2.1 million. And then we've raised well over another $1 million in donations, donor advised funds, private grants, and foundation endowments to stand up the first prototype factory. So as we go to market by the end of the year, we will have 0 capital expenses to amortize into our product cost. In other words, 0 CapEx as we launch. Then also going forward, we can partner with third-party owner investment companies who have tax appetites and can take advantage of investment tax credits and depreciation along in the lines of the standard power purchase agreement, where investors can take advantage and are attracted to tax-advantaged investment opportunities. So by combining these things in a purchase and leaseback arrangement, we combine the best of all worlds in essentially a partnership with the federal government, who understands that local 501c3 organizations are best at enacting local projects. And so the federal government essentially partners with nonprofit organizations by supporting them, by relieving them of taxes. So this is a wonderful opportunity that we get to use all of the tools available to us in the American economy. That helps us compete with the Chinese command economy, where they just set prices from the top. We always have a number of sophisticated options, levers and dials that we can pull to bring our prices within line of the world market. Okay, so let me describe to you the real innovation here. We have an opportunity now with solar energy, renewable energy, to relocate the economic driving force of this production. We have a strategic alignment between the 2 cities of Pomona and Claremont. And as of right now, before the factory was created, with regard to energy, specifically solar panels and many other products and services, if the city of Pomona or Claremont want to deploy solar, the first 20 to 25% of that investment in the form of solar panels must necessarily leave the local economy. It creates an economic leakage. And so, as we know, with the example of a solar panel, that economic expense, that capital expense, leaves not only the local city, but it leaves the state and it leaves the country, creating a massive billion-dollar trade deficit at the federal level with regard to solar panels alone. So what our goal is to create a little bit of economic vacuum that attracts investment and resources into our local economies, minimizes economic leakage so that we can then actually regenerate economies from the ground up. So what I'd like to do is just show you a little quick graphic of the city of Pomona. We have all of the anchor businesses, and we have the municipal government, we have the Chamber of Commerce, we've got businesses throughout the community, and we've got all the homeowners. In the case of Pomona, 35,000 homeowners. So what's happened, of course, over the last 50 years, due to globalization and multinationalization and the idea that somehow, if we support the profits of multinational corporations, there will be a trickle down at the local level. We now understand that that's never going to happen. There has been nothing but economic flight and economic leakage inside and from our local communities. All of the anchor institutions now inside the city of Pomona are forced to buy goods and services from outside the community. The municipal government is the same. And now also let's focus on energy. Let's think about these households inside of our local communities. And we've taken the math on 6,000 of our lowest household income families and computed that every month, when you think about it, these households are spending at least $90 a month on electricity. And that $90 a month times 6,000 times 12 months in the year ends up to be about $6.5 million a year that our lowest household income families are sending out of the community to the utilities to be essentially burned up every month. That's a huge economic leakage at the low income household level that we could be capturing if we made and distributed our own energy in our local communities. So what we want to do, of course, is minimize economic leakage, bring in opportunity to the center of our cities. We've engaged the local municipal governments, of course. We've engaged our anchor institutions, and we've engaged the Chamber of Commerce and also the state of California to launch the first CHERP Solar Works factory inside the community. Then we'll, of course, bring other economic partners with us. And the idea, of course, then is to actually be able to sell goods and services, and in our case, the solar panels, to the local anchor institutions, hire local labor that can walk or bicycle to work, which is another GHG mitigation effort. And now we can actually make products and services inside our local communities for our local community, which creates what we call the virtuous economic cycle. So let's take a look at how this works from a sustainable energy perspective and a sustainable economics perspective. I talked about those 6,000 households that are now currently spending $6.5 million a year outside of the local economy. So what we do is we align all the state and local resources to be able to create and fund a locally grown power factory inside the local economic unit, the city, the community. That locally grown power factory now can create energy for the local community. In our case, we're going to be launching that through the community choice aggregation designation in the city of Pomona. The minute we provide community solar for those 6,000 low-income households, it's like flipping a switch. We're going to provide free energy for the lowest household income families to directly attack are justice and equity issues in this country. That's like flipping a switch and redirecting $6.5 million a year back into the local economy, because we know that at the lowest household income family level, the marginal propensity to consume those extra disposable personal income dollars in the local community is much, much higher than at the high household income level. Those dollars, since those families live paycheck to paycheck, now get diverted into essential spending needs. That hits the retail economy. The retail economy starts to grow. They also hire indirect jobs. And we've now created a virtuous economic cycle where profits are being reinvested in the local community to the tune of millions of dollars a year. That, of course, spins up local and regional and state sales taxes back to the state level. And we've shown through regional input-output models that this kind of economic activity can actually pay for itself and pay back any investment from the state in under 5 years and double their money in under 10. Okay, so I'm going to take you through a very concrete example using the power purchase agreement. All of you, or many of you probably in the energy field, are aware of the power purchase agreement. What we ran into before we opened the factory in Pomona is the Pomona Unified School District, with about 30,000 students and 40 buildings, have been casting around for a partner to help them create energy, renewable energy for the school district. What they discovered is the best company that they could find before we opened the factory was a company out of Delaware. So what we have are school districts and cities who've been nonprofit organizations who can't take advantage of their own investment tax credits and depreciation. We have these nonprofit anchor institutions going to companies even outside the city and outside the state to satisfy their desire for renewable energy. So let's take a look at what that does to the macroeconomics of a community. If you hire a company from out of the state to come in and supply energy for you as a nonprofit anchor institution, you will, of course, not be creating panels inside your local community. That is what we call a huge economic leakage outside of the local community, because those dollars that you're spending on your new solar panel will never hit your local community. You will never create a local factory. So the factory labor that's being created by making the millions of dollars worth of panels is also an economic leakage. The installation, oftentimes by that company from Delaware, is from a national partner. And so oftentimes the installation labor is also an economic leakage. Oftentimes the operations and maintenance function is also subbed out to national partners. So we lose the opportunity there as well. The profits, of course, over the next 20 years of that power purchase agreement with a company in Delaware dealing with a school district in Pomona will be extracted out of the community for the next 20 years. There will be no low to middle income energy projects focusing on our lowest household income families, so that will be non-existent. The school district, of course, will save some money on the kilowatt hours, and that will hit the local economy. But then there will also not be any local investors involved, because mostly these are national investment companies that come into the local community. So we have massive economic leakage with a little bit of benefit at the renewable energy kilowatt hour level, as opposed to our model, which is going to locate each one of these stacks, each one of these levels of the entire energy deployment stack inside the local economy. Each one of these will have a multiplier effect on the local economic economy and minimizing this huge opportunity cost and multiplying the recirculation of these dollars by a multiplier of approximately 10 or 7 based on our input-output models. Okay, so very quickly, how does this work? CHERP Solar Works will inspire the creation of a locally owned factory. In this case, we are partnering with an organization in East Los Angeles called Homeboy Industries. We're going to help them build their own solar factory that they can own and operate, along with all of their other social enterprises in East Los Angeles. That will give them the opportunity to address their market. All of the anchor institutions, the school districts, the governments, the universities, the hard-hit small businesses with solar energy. So now we can partner, they can partner with a third-party owner investment company, or now if this direct pay happens, we won't even need the investment company. The government will directly pay the offsets that ITC and Macros was giving before. But this will allow Homeboy Industries to stand up solar systems under what we call a values-aligned power purchase agreement, keeping all of that activity local. And then so the school district can save money. And the local school district is paying approximately 23 cents a kilowatt hour. And since we can stand it up for about 6 cents, the local 501c3 will be making lots of profits on that deal, just like the ESCO company would be from Delaware. Now, the difference here is, of course, those profits are not leaving the local economy. They're staying inside the local economy in that 501c3 so that we can now address our charitable class of local low-income homeowners so that we can then stand up community solar projects through the local community choice aggregation designation and provide free energy using the profits of the solar sales to provide free energy for our low-income household families that can now then reinvest that money on top of everything else back inside the local economy. So we've tied a ribbon around the entire value chain inside the local economy. Okay, very quickly, I'm going to wrap up by showing you that each one of these locally grown power factories will be knit together in the National Locally Grown Power American Solar Manufacturing Network. So as you can see, each one of these separately and locally owned factories will be creating an economic engine inside their local underserved community. But the entire network is also a nonprofit network controlled by a nonprofit board. The intellectual property accrues to the network, and the network can never be rolled up and sold for profit by a for-profit entity. This entire network, you can see, then ultimately creates a mega solar factory, taking advantage of all economies of scale that any one mega factory located in some community in the country could take advantage of. This is a nimble, very flexible, equity and justice focused mega factory located in the heart of the communities where we need the jobs and the economic activity the most. This entire network is designed to be regenerative and not extractive in nature at the local economic level. So the numbers are very impressive. One factory mitigates thousands and thousands of metric tons of CO2 once we start deploying panels. Each factory will create over 700 direct and indirect jobs, stimulates the local economy by $147 million after 15 years, and addresses our low to middle income equity and justice issues by providing free energy for thousands of households. This entire model is designed to be scalable. The prototype is now being finished in Pomona, California, and we're looking to replicate. We're in conversation with 15 other cities around the country right now, and we're getting ready to launch what we call the LA Factories for the Future in LA County. And I want to just summarize and quickly wrap up with this model. I want you all to think about what this might mean in your own jurisdictions. Los Angeles County has a sustainability plan that they claim is the boldest county sustainability plan in the nation. We are all in this county very excited about the sustainability plan. And one of the many goals of this plan, many goals of this plan, is goal 7A, which is focused on energy. That goal 7A has put a stake in the ground, an aspirational goal of distributing 10 new gigawatts of distributed energy resources in LA County alone by 2045. So the problem with this goal, as we all now know, is that if you do the math, 10 gigawatts of new energy in LA County equals about 30 million new solar panels being distributed in LA County. So what we have here is a gap between our sustainable aspirational goals and our economic realities, because 30 million solar panels will cost $5 billion. And currently, that $5 billion will leave not only the LA economy, but the California economy and the economy of the country. So we have a very simple solution now that didn't used to exist before we have the opportunity to create our own mini solar factories inside our most disadvantaged communities throughout LA economy. So our proposal is to create 15 factories inside LA County. Let's make the 30 million solar panels, the solar modules in our case, inside LA economy. Let's create over 10,000 jobs, invest the $5 billion locally, which with our multipliers, of course, will grow in that amount of time to over $35 billion in GDP expansion. Let's do all of that now locally. So we're getting ready to launch on October 1 our LA Factories for the Future as a symbol and a model for the rest of you in the country to be thinking about how we can now address our climate goals along with our economic realities and address our social and environmental and justice issues all at the same time. So we are open and we are ready, and we're really happy to be talking with you today. So what I'd like to do at this moment is to introduce the inventor who came up not only with the technology, but this deployment model throughout the country. His name is Kent Kernahan. Kent, over the last 7.5 years, we met back in 2015. Kent and his whole team at idealPV have become extraordinary friends and mentors to us as we contemplate this novel technology and deployment mechanism. And so I'd like Kent to kind of climb on here, introduce yourself to everybody. I'd like you all to get a kind of a flavor for Kent. And Kent, maybe you could make any comments about what I've left out or anything you'd like to underscore for this presentation. And then we'll all be around along with Professor Haskell, who's been doing the experiments on our technology for question and answer. So Kent, take it away.
Well, thanks. Hopefully everybody can hear me. Megan, you're my monitor. Sound okay? Everything good? All right, excellent. Listen, I want to take you guys back to kind of the beginning. We get asked that a lot, and particular, I see that Clean Technica is out there. I just wanted to give them a shout out. The original concept happened in the beginning of 2011, and Clean Technica was kind enough to publish this article. And basically, oh, great. Well, anyway, Great Recession, My Fault is what it was called. Let's see if it comes back. Interesting. Well, anyway, it's still available on their website. Let's get rid of that stuff. And basically what we did was we looked at this idea that the inventing class of the United States could on its own, by changing the way that advanced technology was licensed, enable business models that concentrated manufacturing back in the United States. So we could create a renaissance of our manufacturing by using advanced technology as a magnet for it. Now, with that kernel of an idea that we could flip the script on what intellectual property was, that intellectual property wasn't, something that was kind of an afterthought, a major corporation acquires it to further its business model. But in fact, intellectual property could be used to drive business models, and it could be drive business models in ways that were accretive to our society. So then what was needed was a technology that fit into that mold. And so what I'd like to do is just give you the barest idea of what that technology is and where we're coming from. So in the era that we have today, we're in the crash and try not to get hurt too badly era in solar. So very, very primitive stage. Think of it like airbags. They only do you any good after the crash has occurred. They're useful for you, although painful. They don't do a thing for your car. That's where we are in solar today. Crash and respond. What FOZHS is about is really akin to anti-lock braking. It's a see and avoid kind of a technology. Now, up to the moment of the invention of FOZHS, the idea was that hotspots could only be detected as something that happened in the past, and so it was all about materials and mitigations and things like that. That is very, very, very expensive. It drives the cost of any solar technology that you might want to employ, and obviously with more power comes more damage potential. And so at the risk of turning a few of you off that might not look at power curves, the big thing to just basically keep in mind is if you operate over there in reverse bias, they generate enormous amounts of heat, more than your ceramic cooktop, more than you had that cooked your breakfast this morning. If you can operate in forward bias, they actually cool. And what we do is we use a math signal to detect when this dynamic conductance is low, when it's sharp, and operate only over here. And it turns out that we came up with a math trick based on Einstein's original equations. That's where he got his Nobel Prizes for solar, that allows us to see that signal from outside a solar panel made with an arbitrary number of cells. So that's the fundamental technology, and it applies to any sort of solar cell or any photovoltaic material. We're starting where we are because this is where the industry is, but you should be looking to idealPV and the locally grown power network to create enormous innovations going forward beyond this point. So I'm going to stop with these, although I've got some other materials keyed up if there's questions on them, and just give you the basic idea that is, I'm one of probably about 400 prolific inventors in the United States. Any of us could do this. Or the new guys coming out of university, maybe some of the people who are interns on our program under the great instruction and mentorship of Dick Haskell and Harvey Mudd. But any of us can do this. Choose to take our intellectual property, create a licensing structure that enables a new business model. In my case, I'm taking advantage of the fact that in the United States, even though 5% of our GDP is from the nonprofit sector, that nonprofit sector does not include manufacturing advanced technology products. So this is designed as a demonstration, as powerful as it is, of just one technology employed in that model, leveraging our nationwide 503c network of nonprofits with the brilliant volunteers and the people that support them to create our competitive renaissance to the command economies that we're up against other places in the world. Now, I like our solution because it's based on volunteerism and altruism and strategic thinking. Obviously, we've taken advantage of you know, things like GDP multipliers and concentration of economic activity to make it work even better. And it turns out that low income people have the highest propensity to consume. So not only is it, as my dad would say, as a Methodist minister, you know, it's the right thing to do. It's the right thing to do. It's right from a societal point of view. It's also the way you get the maximum gain for your economy is to enable those people at the lowest end of the economy to flourish. So, you know, welcome to the future and locally grown power. This is just the very first little magic bean of this great journey that we're going to be on. And I really look forward to, you know, not just the fruition of locally grown power, but also the promulgation of this idea that our inventing class can really provide this solution to us.
Great, thanks so much, Kent. I really want us to get to questions since we're almost at 11. This is Rosanna Francescata, by the way. I'm a communications consultant with Seneca Solar. If you have questions, feel free to raise your hand. I thought I saw one there, but I'm not seeing it now. So we'll get to some of the questions that have been answered or asked in the questions pane. But you can raise your hand at any time and we will unmute you. You can talk directly to the CHERP folks. So we have a number of questions that are still open here and some have been answered as we go. We have Michael Whitmer has his hand raised, so I'm going to allow him to talk and then we'll get to some of the other questions. Okay, Michael, I think you should be able to unmute yourself.
We good?
Yep.
Go ahead.
All right. I have been watching with great anticipation the start of production at CHERP, and it keeps receding. It has deadlines have come, or expected dates, launch dates have come and gone. I'm not sure it's productive to ask about why, but I'm curious why you're confident that you actually will go into production at some specific time in the future.
Yeah, great question, Michael. Thank you. Many people have been patient with us. We have stood up this factory. We started launching the factory right when COVID started. And we have been facing extraordinary headwinds with supply chain and shipping, which created the opportunity for us to switch chips. We all know that there was a huge dearth of chips available, so we had to switch. And so that created an opportunity for us, but also slowed us down to redo the coding for the entire operational system in the back of each solar module. And so that's pushed us back several months. The good news, of course, is that now during that time, we took the opportunity to make the coding and the offering even better. There are a number of advancements that have happened over the last 8 to 9 months. 6 new patents are now pending as a result of that work. We decided to just bite the bullet and make this product that's coming out now that much better. So we're getting ready to submit to ETL in the next few weeks. And then in about 2.5 months, we should be certified for deployment. So we're looking for a December certification at this point, and then deployment first of the year with panels on all of our pre-purchasers and some of the letters of intent that we're working on with anchor institutions. So, yep, it's been an interesting landscape to launch this project in, but we are now nearing the finish line from a certification perspective. And the certification really for us is kind of a bump in the road. It's not a matter of if, it's just a matter of when. The certification is about safety and not about performance. And so we're anxious to get this on the market, because not only will it be the safest panel on the market, but it will also be the highest performing, efficient, and least degrading panel on the market.
Thanks, Devin. It definitely has been a challenging time. We have a couple of questions about recycling. One person asks, I'm interested in the raw materials and waste management parts of the system. What consideration has been made or is planned? And that was Hydron Lumperdrum, and Beverly Deshaw asks, a challenge that we keep hearing and promoting EVs and renewable energy is that solar panels are not recyclable. Of course, we know that there is recycling going on, but
Yep.
what are the provisions being made for recycling? Is that something?
Thank you, Hydron. Thanks for checking in and being here. Kent, I'll pass that over to you.
Yeah. So we were really concerned about that too. And one of the things that is true about the legacy solar that exists today is it is really meant to be a one-shot deal. When a panel reaches end of life or is damaged, then that's it. It's torn apart into its component pieces, and those are recycled. So the first thing about recycling is don't do it. Actually make a product that is very long-lived and is serviceable. This is our junction box. It's galvanized steel. It's actually stamped out at the individual factories. But the important thing is it's put together with RTV, so it can be taken apart with an X-Acto knife. The board has 4 connections. So the boards are replaceable. The boards themselves are designed with wide spacing and room to be able to be serviced, unlike most microelectronics today. The solar cells themselves are put together in such a way that the back can be opened and cells that have failed can be bypassed and then reapplied UL approved Tedlar tape and put back into service. Because the technology is so flexible with regard to damage and resiliency, it's also going to be a long time before you need to do that. We had a solar module that received something like 70–80% damage in a shipping accident to the cells that still produced 83% of its original power. So would have actually been deployable, even though almost all of the cells had pieces broken and cracks and other kinds of damage. So it's a combination of making all of these things very resilient, and then of course having the factory that actually builds it and can take it apart in the same community, as opposed to trying to manage some sort of a waste stream. So that's it, you know, in terms of strategy. Make it very long-lived and durable, resilient, make it so that it can be repaired, and then ultimately so that it can be taken apart.
Great, thank you. Did you want to say something else? Sorry. Okay, another question we've gotten from Billy Romaine is about job quality and workforce standards. Do you have worker representation and partnerships with labor unions, or what kinds of workforce standards do you adhere to?
Yeah, the workforce development piece is huge for us. Megan is in charge of all of that in our factory. We have formed a partnership with all of the workforce development programs in LA County, starting at the top of workforce development in the county. We have designed specifically 75% of all of the job descriptions inside the factory to be workforce development focused. So what we're going to be doing is creating an environment of support, both on soft skills and professional skills. And we will be bringing in new targeted populations for training and bringing them back into the workforce, training them, and then moving them up and out to other industries every 9 to 10 months. So every year we'll be rotating and creating more than one full-time, up to about 1.25 or 1.3 FTE equivalents in the factory every year. So we're definitely in concert with and in discussions with not only the local unified school district, but also at the county level. And in all of our other core energy groups that are forming around the country, they are also encouraged to form networking relationships with all of the local workforce development agencies and programs.
Great, thanks. And just a reminder, don't be shy. If you want to raise your hand, we can unmute you so you can ask questions directly. We have a question from one of our staff, Miles Caldwell. Will these factories be retrofitted from existing factories, newly constructed, or a combination?
Yeah, that's a really good point. It actually will be a combination. The originally conceived model and the one we used in Pomona was that we found an empty and unused warehouse space owned by the school district, and we formed a great relationship with them and are leasing the space from them at a very good rate. The tenant improvements required to go into that particular situation are probably under $200,000. We're involved in an EDA grant right now in Southern California. And if that goes through, we'll be building 3 factories for 3 separate tribal nations in San Diego County, one of which will go into a failed casino attempt and doing some tenant improvements in an existing building. And the other 2 factories will actually be created from the ground up.
Great. We have a question about the panels from Mark Buckley. Are they EAT compliant, and if not, could they be?
I'll let Kent dig in.
At least at a high level.
Okay, do we have the right letters? EPTA?
EPEAT.
Yeah, what is that?
I don't know what that is.
Yeah, I've got an awful lot of acronyms, but that isn't one of them. Could the question...
All right, well, let's move on for now, and we'll get back
Stands for the Electronic Product Environmental Assessment Tool. It's I believe it's a life cycle analysis.
And I'm going to get to a couple of raised hands, but if you can answer that, and I also have another interesting question here in the chat that I'd like to ask. So should we move on to that? Or...
I think we can move on to that, but in terms of the life cycle, yeah, we've actually spent a lot of time considering that, but I'd be interested in looking at what that certification is.
Great. This is a very relevant question in California right now. What happens to the financial model if the utility companies enact a tax or fee for solar users? That's from Dan Posnick.
Yeah, thanks, Dan. Yes, obviously, we are all in a struggle with the utilities to protect and levelize the playing field and not necessarily penalize solar. Our play right now, however, I think the largest play in this particular model is the development of community solar projects and the selling of energy to PPAs. And so the selling through PPAs. So the selling of energy and the creation of those projects and profits will then be used to create community solar projects through the CCA, the Community Choice Aggregation City, because they're allowed now to purchase their own energy and to sell that at the local community. So that would be kind of outside any net energy metering considerations that's going to really deleteriously affect the rollout of rooftop solar in California. So we all need to rally and help resist that movement at the utility level.
Yeah, and speaking of PPAs, I'm wondering if you've had any time to dig into this, but with the new provisions in the Inflation Reduction Act, that could really open things up for nonprofit entities to get direct pay instead of a tax credit. Have you looked at how that will affect your model?
It just cleans the model up. Even it just removes an entire step inside the model and increases the profitability of the solar deployment model, because it eliminates a third partner in the stack.
Yeah, it seems to me like that's going to be huge. All right, I'm going to unmute a couple people. Kathy Curtis has a question. So Kathy, you should be able to unmute yourself now.
Hey, thank you so much. Really exciting to hear what's happening. Devin, you have done so much. I just can't even believe it. Anyway, love to reconnect with you sometime soon. My question
Yes.
is about batteries. You know, one of the things that I know is important to consider is batteries for if you're doing a solar connected installation so that you can take advantage of time of use rates, so that you can load shift when you're using your own juice versus when you're using the utilities power. And secondarily, I'm always really interested in the emergency preparedness aspect of having your own battery power. So if you have to island yourself as a home during an extended outage and have a few circuits keeping your fridge going, you know, is there a battery element to your plan, and how might that fit in?
Oh, absolutely. Yeah, batteries are kind of an integral part of every analysis that we do. But we have the technology speaks to that in some very interesting and unique ways. So Kent, maybe you could respond.
Yeah, first I just wanted to talk about the model for accessing idealPV modules will typically be through medium, large scale commercial applications on large, buildings or city hall, casinos, brownfield installations, things like that, using power purchase agreements, community choice aggregation to then make the energy available to everybody, as opposed to a house by house kind of an install. While it's technically feasible, obviously the cost factors involved in working on each house and dealing with each roof isn't really a large-scale model for energy distribution. So I want to just kind of get that part out of the way. Within that, there will be applications that are not traditional applications in cities. The solar modules themselves are programmed to look enough like a solar panel to work with an inverter in a city and in the applications that we've been talking about today. But we also have other software loads that were also in our field trials that talk directly interactively with batteries. And those are meant for, profound off-grid applications where there's no, interconnect anywhere else, as well as, direct drive of well pump controllers to basically allow for remote ag, put a well in the middle of a pasture and water your horses and your cattle and that kind of thing. So there are applications all the way down from the profoundly rural all the way into the commercial end of it. In terms of the storage that happens for these large scale, that will typically be more of a grid scale. So these are larger battery installations meant to back up large portions of the community, or pumped hydro systems, either small scale ones within larger communities, or shares in larger pumped hydro storage. There will be obviously independent, individuals that have these that, have a power wall and all of that, but that's not our primary focus.
Got it. Thank you so much.
Great, thank you. And I have a question from Billy Romaine, interested in toxic materials use and byproducts in the manufacturing process. Is it similar to conventional wafer production?
Go ahead, Kent.
So right now, we're not including wafer production within the individual factories. And so we're taking the individual cell supply stream from wherever we can get it. Having said that, we can use upgraded metallurgical silicon, which has far fewer inputs than traditional microelectronic grade silicon. But this opens the door to things like dye-sensitized solar, which is an entirely organic technology that's also in development at Harvey Mudd, and other thin film technologies that are either very adverse to heat or very adverse to reverse bias, or both. And so right now, we see them in the laboratory. This is what's going to allow those to emerge into mass deployment.
Great. Okay, we have a question from Tammy Parker. Tammy, I'm going to allow you to talk. You can unmute yourself. Tammy, go ahead and unmute. All right, I'm going to move on to the next person. If I think we had someone with Okay, let me try that again. Can you unmute? All right, I will move on to another question. Here's one that I think is important. Martin Webb asks, what do you want from us exactly as attendees of this webinar?
Oh gosh, that's a great question. Thanks for asking that. As I mentioned before, we are now currently in conversation with about 15 other groups around the country who are interested in launching a solar factory. We're forming what we call core energy groups. Sometimes that can start with an individual who wants to be able to launch this opportunity inside their own community. We work with that individual or organization to help develop a group around them, a core energy group, representing the local elected officials, the business community, energy experts, communities of faith, local universities, and community colleges for the internship and education and job creation and training aspects. So we have a number of groups that are forming, and their goal is to get networking at the local level to sufficient levels of cohesiveness to be able to start identifying a 501c3 organization in your local community that can take on this project, identify a location, which we need about 15,000 square feet with about 20-foot high ceilings with a loading dock. That's the essential location that in which 15,000 square feet, we will be able to create a 30 megawatt solar module assembly factory, creating about 100,000 panels per year. The cost of duplicating these factories is right at about $6 million. From soup to nuts, it's a turnkey operation. What we do is we'll come in and help you create, design, order the materials, the equipment from all over the world, and have that come in, and we will commission and help you install and set up the factory line, get your certifications, and help you hire the people necessary to run that factory. So that's really what we're doing. We're now in replication phase of helping you create a kind of a factory in a box opportunity for a local 501c3 that would want to take this on, or you could form your own 501c3, and this is the project around which you would be forming.
All right, I think I just want to give Tammy a chance to try to talk because it looks like she's maybe managed to unmute. So why don't you go ahead and then we can wrap things up soon. Tammy, are you there? Okay, well.
I see another question here. Don't forget, everybody, that the website, our website, CHERPLGP.org, CHERPLGP.org, has a huge amount of information. So if you go to factory and then go to start a factory, you will see a one-pager there, the 8 reasons document, we call it, for local elected officials. It's talking points. It's the 8 reasons, the highest level reasons why you would want to have a CHERP solar factory in your community. That's for local elected officials and just talking points. And then there's also a factory startup handbook delineating all of the steps and the highest level operational components of starting up a factory. So that's there as well. And then in the video section, we have an entire YouTube channel, and you can see 4-minute animation videos talking about our entire model. You can see Kent describing in detail some of the physics going on inside the technology. We have actually a drone video tour of the entire factory in operation. So there's a lot of collateral material that you can use to educate yourselves and then also to share with other members of your core energy group to bring them up to speed.
Great. Well, thank you so much. Yeah, can't go. I'll let you go ahead in a minute. I just want to remind everyone, you can follow Seneca Solar and CHERP on LinkedIn. I put the links in the chat. You can contact us at info@senecasolar.com. Check out our website. We will send everyone the recording and slides as well. And Kent, did you have some final words there?
Well, I just had a couple of follow-ups to one question that had to do with the material stream, because I think this is important. The technology eliminates a lot of the specification that is required for conventional solar cells. What this means is that many solar cells that are out there in the stream that are not suitable for use in panels, they would be scrap material with all of their embodied energy lost, additional embodied energy used to recover the precious metals that are in them, are actually usable in these modules at full rated power. And so from that perspective, they actually have a negative impact on the stream because they can suck up large amounts of material that would have actually been in the waste stream and put it into productive use for decades. The other point I wanted to make is that an interesting note that I think we can announce here for the first time, at least in public, is that we did not have to sacrifice any of our safety features to get a safety certification. That may sound paradoxical, but there are so many intrinsic risks built into legacy solar. I'll just give you just this one. Our technology has current limiting and short circuit detection and protection. Legacy solar panels do not. For a hot minute, or for really about 3 weeks, it looked like we were going to have to delete our feature in order to get certification for safety. That is, make them more dangerous. ETL, to its credit, really took this all the way up their chain of command and came up with a novel way for us to be able to actually get certified and have our safety feature. And that's one of a dozen safety features that we had to negotiate to keep. But in the end, we didn't lose one.
Okay, thank you. I'm going to try one more time to unmute Tammy Parker and allow them to talk. We'll give that another try. If that person can try to unmute. Okay, it looks like you're unmuted.
Hello?
Yes, we can hear you.
Can you hear me?
Yes.
Okay, this is Arlen Kutowski, senior current councilman, former governor for the Zuni tribe here in New Mexico. I've seen your presentation. It's very interesting. As mentioned here within our tribe, the financial portion of it is, as mentioned, it's going out of our community, but we want those profits back here so that the money stays in here. But one of my questions is that, well, I've got a lot of questions, but one of them is, how many tribes in the rural communities have you been working with, or so that we could actually see if what would happen within tribes? Around Zuni, our reservation, there's cities like Gallup, Grants, and then other tribes have done solar farms and whatnot, but we've been thinking about possibly doing a manufacturing of solar panels. So that's one thing to also look at possibly doing. So when the presentation was made and looking at the leakage of the finance, of the money going off of a reservation, the idea of developing those and also looking at the future of our community, especially our youth, to develop something like this and entice them to go get their education. So we have a facility here and you have a job. You will have a job when you get your degrees and education. So those are some of the things that we're looking at. So basically my question is, have you worked with Native American tribes that are coming from very rural communities like ours? And if not, then you know what, I'm looking at a very good idea here, but can it work for us here in our community if we want to go venture in what was being presented today? Thank you.
Thank you,
Good.
Councilman. Yes, really appreciate the question. And we've been following what's happening on in Zuni tribe relatively closely. So it's really an honor to have you with us today. I agree. I think this is a great opportunity for tribes and pueblos where appropriate. I would love to hear Devin's thoughts, but it's on our mind and it's something that we're very interested in discussing more with folks who are actively interested in manufacturing on tribal lands. Devin, did you want to respond?
Just real shortly, we from the very beginning, we have always thought that this would be a perfect partnership with tribes across the country. And our only current exploration into that right now is the EDA grant that has already been submitted. We'll know more about that in September. If that is accepted, we'll be moving forward with 3 tribes in San Diego County. And they are, at least one of them, very rural. So we're very open and excited to the exploration of possibilities on tribal lands throughout the country.
For Zuni here, our closest city is 45 miles away. Another one is 75 miles away. And on the east end, Albuquerque is 150 miles away, but our community still goes out there and shop and spend all their money. So the leakage is it's happening. So
yeah, that's right.
If we get the finances and develop something like that, as you were mentioning in your presentation, the money stays here to develop supermarkets, grocery stores, malls and whatnot. So the money stays here in our community. And I think that's one thing that we've always been saying is let's take the business away from these cities and bring the money back to our community. But how can we do that? And if this is a source to do that, then that's something that the tribe should seriously take a look at. If it's feasible and possible to do that, that's something that we need to start looking at. Thank you.
Great, thank you. And thanks so much for joining. And thank you to everyone who's stuck with us this far. We really appreciate it. We're very excited about this model and hope you are too. And we will try to follow up on the questions that we did not get to during the webinar. You can always contact us as well at info@senecasolar.com. And we will send you an email with the recording and slides. You can also respond to that. So thank you very much. Thanks to all our great presenters.
All right, thank you.
Bye-bye.
Thanks, everybody.